Identify the core chemical concept tested. The question tests your understanding of the electrical conductivity of aqueous solutions. For a solution to conduct electricity, it must contain mobile, charged particles, ions, that can move freely through the solvent to carry an electrical current. Analyze each of the three solutes to determine its behavior in water. HC2H3O2. Acetic acid. This is a weak organic acid. When dissolved in water, it only partially dissociates into H to the power plus and C2H3O2 to the power negative ions, meaning the vast majority of the molecules remain intact and uncharged. It is a weak electrolyte. Ki, potassium iodide. This is a highly soluble ionic salt. When dissolved in water, it dissociates completely into its component potassium ions, K to the power plus, and iodide ions, I to the power negative. It is a strong electrolyte. CH3OH. Methanol. This is a covalent molecular compound. Although it is polar and dissolves well in water, it does not dissociate into ions. It is a non-electrolyte. Compare the concentration of mobile ions in each solution. Because all three solutions share the same initial solute concentration of 0.1 molar. The 0.1 molar Ki solution undergoes complete dissociation to produce a high concentration of free ions, approximately 0.2 molar total ions. The 0.1 molar HC2H3O2 solution yields a very low concentration of free ions due to limited dissociation. The 0.1 molar CH3OH solution yields virtually zero free ions. Conclude which solution has the highest conductivity. The potassium iodide solution, 0.1 molar Ki, has by far the highest concentration of mobile ions and will therefore exhibit the greatest electrical conductivity. This corresponds directly to option B. The correct answer is option B, 0.1 molar Ki, because Ki completely dissociates in water to produce ions.